Hello everyone, my name is Jean-Christophe, and today I'm going to teach you how to use Sklearn linear regression to make a multiple linear regression in Python. So a linear regression is using ordinary least square to predict value. So essentially, it uses the sklearn linear model, linear regression class to fit a linear model to minimize the residual sum of square. So we're trying to fit a line on this data that is as close as possible as all those blue data points by saying we give an intercept, we give a slope, and we fit that line, and we try to minimize the sum of these green lines, essentially. A multiple linear regression, what it does is similar to what a simple linear regression does, but it models a relationship on one dependent variable on two or more independent variable. So essentially, we're trying to fit multiple lines with the same intercept on the data, and we try to minimize that residual sum of square. So if we look at a primer on linear regression, we had a previous tutorial where we ran this and we essentially loaded the data and we selected just one of the features. So we just looked at BMI to predict diabetes. We split and trained and testing data, and then we fitted the model, we predicted the y, and then we computed the metrics. We had some subset of metrics results, and now we're going to see the difference between this and a multiple linear regression. So with the multiple linear regression, we're going to keep all the features, not just BMI, but all of these features in order to predict diabetes. So again, what we're going to do is we're going to split training and testing data so that we can evaluate the score later on. And to do this is with train test plus, and I'm not going to go into details of how we do this, but we get the X training data and Y training to train our data set, and we're going to use X test to predict Y pred, uh, and we're going to compare Y pred with Y test. In order to do this, we are going to train our model with from sklearn, and linear model module is where you will find the linear regression. So, okay, so we do this, we are splitting the training in data, and then we train the model. So we do linreg, and we do equal linear regression. So we just instantiate the model here, and we will use this class of linear regression to fit. So fitting means training. So we pass X train and Y train. So we're training on the training data, not the original data. And then we do Y pred equals linear reg predict. And then we try to predict X, use X test to predict Y. Then we run this, and we have performed a multiple linear regression. In order to really go into what it means to do a multiple linear regression is in the interpretation. So far we've had all the same steps as earlier. Now what we're going to do is we are going to show how it impacts. So you do data frame. So we're going to do a data frame that will add all the linear regression coefficient. Earlier, we had just one coefficient because we had just one feature. Now we have multiple feature and we will have multiple coefficients. So we use the coefficient attribute and we plot X columns, and then we give a column names, and we will name this as coefficient. So this data frame will help us making a plot, and we will plot all these data into a bar plot. We use the pandas plot function to kind bar h. We're going to give a title, x label, and y label for some information, and then we do plot show. Now we try to plot this data, and what we see is that for each of the feature, we have the coefficient and which one impacts the most the variance of the body mass index. So we can see that S5 and S1 have big impact here. And now we are going to look at each of those metrics. So this is the difference. Earlier, with a simple linear regression, we had only one of these coefficient, and now we have all of these. So we are going to compute the accuracy of this by using Sklearn metrics from sklearn.metrics. And essentially what we try to compute is the R2 score. We try to compute the mean absolute error, and we try to compute RMSE. So we are not going into the details of how to calculate this, what they mean, but here I'm going to show. Sorry, I have a problem here. Import metrics. And then to calculate the R2 score, there is a convenient uh, function in metrics. So you just pass in y-test and you pass in the result of your prediction, and it will calculate R2 score for you. Again, with metrics, mean absolute error is mean absolute error. And again, you pass it y-test and y-pred. And lastly, we are doing metrics dot root mean squared error. So if you don't know why I'm doing this, I have tutorial on each of these. You can look at them, but essentially we're predicting the metrics. Um, how do you interpret this? We earlier we had a simple linear regression. These were our metrics, and now we have a multiple linear regression, and these are our metrics. If we look at this closely, we can see that mean absolute error is lower, the RMSE is lower, and the R2 score is higher. So what the mean absolute error says is the average absolute difference between what you predicted and what really happened. So the lower, the better. And in this case, multiple linear regression was lower. Similar, the magnitude of error, you want it as low as possible, and with multiple linear regression, it was lower than simple. And lastly, you want to look at coefficient of determination. So you want to know how much of the variation in the body mass how much of the percentage of the variation in the progression of the disease, how much of it is explained by all your independent variables. The higher it is, the better it is, the better fitted your model is. So in this case, having multiple linear regression is better for all three of our metrics. Uh, so in this case, we absolutely wanted to use a multiple linear regression. We could have further improved those core by doing some data pre-processing or hyperparameter tuning, but this was outside the scope of this course. So this was it for this tutorial. So please help me and subscribe to this channel, and see you in the next tutorial.